matrix multiplication. Does AB equal BA? Nope. No, matrix multiplication is not commutative. Can't do it in both orders. All right, if you're multiplying two matrices and if you have an m by n and you're multiplying by an n by p, what are the dimensions of the resulting matrix? M by p. Yep. So when you're multiplying matrices, in order for it to be valid, in order to be able to do it, the inner dimensions have to match, right? The number of columns in A has to equal the number of rows in B, and the result is the outer dimensions. It's M by P. All right, if A is an M by N matrix, what is A transpose? N by M, right? Because the transpose just makes rows columns and columns rows, so it's going to switch the dimensions. All right, so before we start the lesson on 2.1, I just want to remind you that test 1, exam 1 is going to be on Monday. So I swapped the day for exam 1 and the day for 2.1. So your exam 1 is on Monday. It's going to be on chapter 1, except for the parts of 1.10 that we didn't cover. We just did that one little thing about the migration matrix in 1.10. So basically all of chapter 1. And I did give you a study guide with solutions, some practice problems and solutions last class. If you don't have that, you can ask me for it after class. It's also posted in Moodle. Okay, so today we're going to learn about how to do more arithmetic with matrices. So we're going to learn some methods, how do you do it, and some important properties of matrix arithmetic. So I took a little bit of notes on the reading. The arithmetic that they talk about is addition, multiplication, and transposition in the text. And we're going to do a little demo of all of those things. Okay, so if I have matrix A, matrix B, vector C, matrix D, I want to find each of these things. I want to do A plus 2D. So how do I do that? So I'll write it out. So I've got A is 2, 1, 0, negative 3, 0, 5, plus 2 times D, which is 1, 1, 1, 1, 1, 1. First, you distribute the 2. What does that mean? How do you multiply a scalar by a matrix? Yep, you multiply that scalar by every entry in the matrix. So this is going to become 2, 1, 0, negative 3, 0, 5, plus multiply every entry in this matrix by 2, so I get 2, 2, 2, 2, 2, 2. Yeah, how do you add matrices? Add up corresponding entries. So to be able to add two matrices, what has to be true about them? Same rows and columns. They have to have the same dimensions. And then you just add the corresponding entries. No, they have to be exactly the same dimensions. Yep. No. Nope. It's not defined unless they have exactly the same dimensions. So we add up the upper left and the upper left, the middle left and the middle left, lower left, and then we add the second columns. So I get negative 1, 2, 7. Not too bad, right? All right, what if I want to add A plus B? Yeah, different dimensions, can't do it. Yeah, undefined, invalid. A transpose. So what does transpose do? Flips it. You got it. Turns rows to columns and columns to rows. So A transpose, I'm going to look at the rows of A and write them as columns. Or you can think of it as taking the columns of A and writing them as rows. the same thing. So I'm going to have 2, -3. The first row of A becomes the first column of A transpose. 1, 0, and 0, 5. So you see when you do that, my first row of A transpose becomes 2, 1, 0. That was my first column of A. So the rows become columns and the columns become rows. Okay, so I'm going to multiply matrices. So this is new, and it's an expansion of multiplying by a vector, which we've done. So the book gives 2 methods. We'll do this 2 ways. If I want to multiply A times B, 2, 1, 0, -3, 0, 5, times B, which is a 2 by 2, 1, 2, -1, 4. What makes it possible that these 2 matrices can be multiplied? The number of columns in the first one, which is 2, equals the number of rows in the second one, which is 2. So this is a 3 by 2 matrix. This guy is a 2 by 2 matrix. The inner dimensions match, so I can multiply them. The result is going to be a 3 by 2 matrix. 3 rows, 2 columns. So I'm just going to make a note of that so I know what kind of thing I'm expecting when I do this. So I have 2 columns. The first method that your book gives for multiplying 2 matrices is to do it column by column. So if I want to get column 1 of the resulting matrix, I'm just going to call it C1 for column 1. You imagine you're just multiplying the matrix A by the vector 1, -1. Okay. And we already know how to do that. You imagine that that's what you're doing. Ignore the 2, 4. Matrix times a vector will give you a vector. That's the first column of the resulting matrix. So remember, you do, no. Yeah. I'm going to do all of matrix A times the vector 1, -1. That will give me the first column of the product. Because the result's going to be a column, right? The result's going to be a vector when you multiply a matrix times a vector. All right, so you do 2, -3 times 1, -1. This is going to be the first entry of my column result. So 2 times 1 and -3 times -1, and you add them, right? Do the 90-degree flip. Things that lie on top of each other, you multiply, and then you add. So this becomes 2 plus 3, which is 5. So I'll just write it all out. 2 times 1. So that's my first entry of column 1. Then you do the next row, multiply by the vector. 1, 0, 1 times 0 plus 0 times -1, that's 0. And then the last row, 0, 5 times 1, -1, 0 times 1, -5. So 5, 0, -5. That's column 1. Oh, yeah, sorry. Thank you. Yeah, the middle row times 1, -1 should be 1 times 1 plus 0 times -1, which is 1. So 5, 1, -5, that's the first column of the product of matrix A times matrix B. And then you have to do this thing again. And of course, I'm running out of room. I thought I gave myself more than enough. Yeah, we have the first column of the resulting matrix. So we're not done, right? So I have to get column 2. So column 2, I get by multiplying A 2, -3, 1, 0, 0, 5 times the vector 2, 4. Right, then I multiply by the second column of matrix B. And matrix times a vector, we know how to do this, right? So I have 2 times 2 plus -3 times 4, 1 times 2 plus 0 times 4, 0 times 2 plus 5 times 4. So that's -12 plus 4 is -8, 2, 20. That's column 2 of the resulting matrix when you multiply A times B. So AB is 5, 1, -5 is the first column, and -8 to 20 is the second column. So that's the first method. Multiply matrix A by each column of matrix B. That's just a matrix times a vector, which you know how to do, and those things result in vectors that are the columns of the product matrix. All right, and then there's method 2, which is a more sort of arithmetic, do it in one step kind of process. So I have 2, 1, 0, -3, 0, 5 times 1, -1, 2, 4. So here they call this the row column rule. So I'm going to take each row of matrix A, multiply it by each column of matrix B. So I'm going to go, I have to go systematically, and I'm going to start with the first row of matrix A, multiply it by column 1, then column 2 of matrix B, and that's going to form the first 2 entries. That's going to form the first row of the resulting matrix. So I have 2, -3 times 1, -1. You do the 90-degree flip, lay it on top. So you have 2 times 1 plus -3 times -1 is 5. So that's my first entry in row 1. Now I'm still working with row 1 from matrix A, multiply it by column 2 of matrix B. So you do 2 times 2 plus -3 times 4, and you get -8. Then you move to the next row of matrix A. Yeah, next row. 1, 0, multiply it by each column, and that gets you the 2 entries of row 2. So 1, 0 times 1, -1 is 1. 1, 0 times 2, 4, that's 1 times 2 plus 0 times 4 is 2. And then you move on to row 3. Row 3 times each column. Put the result in row 3. So 0, 5 times 1, -1 is 0 plus -5 is -5. And 0, 5 times 2, 4 is 20. So there's our resulting matrix. So, very handy. Your graphing calculator can do all of this matrix arithmetic. So let's put A and B in here. All right, so my matrix A is 3 by 2, and I've got, 2, -3, 1, 0, 0, 5. And then go back into matrix, and I got to put in matrix B, edit B. That's a 2 by 2. And we have 1, 2, -1, 4. And then quick, go to your home screen and go to matrix. Choose matrix A times matrix B. And we get 5, 1, -5, -8 to 20. Same thing we got when we did it by hand. I don't know. I used one when I got my first one in 1996. Yeah. Okay, so we now know how to multiply matrices. What do you think b squared means? B times b. Yep. So this is 1, -1, 2, 4 times 1, -1, 2, 4. Why don't you, for practice, multiply these by hand and then check it on your TI. So we'll do it by hand using the row column rule. Okay. So what is the resulting matrix going to be? What's its size going to be? 2 by 2. So sometimes this helps me to kind of fill out what it's going to look like and then figure out what goes in each box. So then I take my first row of matrix A and I multiply it by the first column of matrix B, and that is the first row, first column of the product. So 1, 2 times 1, -1 gives -1. Then you multiply row 1 times column 2, right? That gives you the entry in row 1, column 2 of the product, right? First row times the second column gives you 10. Right? 1 times 2 plus 2 times 4 is 10. Okay, so now we've taken the first row and swept it through every column of matrix B. Then we do the same thing for row 2 of matrix A. Multiply that one times each column of matrix B. So -1, 4 times 1, -1, that would be -1 minus 4 is -5. So that was row 2 times column 1, row 2, column 1. That's the entry that we were finding. This -5, it's in row 2, column 1 of the product. So now I'm going to multiply row 2, column 2, and that is the entry I'm finding, row 2, column 2 of the product. -1, 4 times 2, 4 would be -2 plus 16 is 14. And then you can check it on your TI. So let's see, matrix B, I think I already have it in there. Oops. So I just have to hit matrix B, and I can just press squared. Your calculator knows what that means. And -1, -5, 10, 14. Got it. All right, B times D. B, what are the dimensions of B? Yeah, what are the dimensions of B? 2 by 2. What are the dimensions of D? 3 by 2. Can't do it, right? The inner dimensions have to match. The columns of B have to equal the rows of D, so this is invalid or not defined. Okay. C times D. The dimensions of C are close, 3 by 1. Dimensions of D are 3 by 2. Can I do that multiplication? Nope. Inner dimensions don't match. Oops. Okay, how about D squared? What are the dimensions of D? 3 by 2. So if I wanted to do D squared, I'd be doing a 3 by 2 times a 3 by 2. Can't do it. Yep, inner dimensions don't match. Invalid again. So matrix multiplication is pretty limited, right? You can only multiply matrices where the number of columns in the first matrix equals the number of rows in the second. Okay, so for your group activities, the first one is just a little practice multiplying matrices, and then the second one is sort of verifying or disproving certain things, properties of matrices. So we want to know If you add matrices, can you do it in either order? If you multiply matrices, can you do it in either order? So rather than doing sort of theoretical proofs, I just gave you some example matrices, and I want you to do this both ways, right? Like I want you to calculate AB, find out what it equals, right? Calculate BA, find out what it equals. Are they the same thing? They will not be, but I want you to do it out just so you can really be sure.